Welcome to WebLizard Lab's CERT Lab. This is AZ-104 Practice Exam 7, Private Connectivity and Load Balancing. You will work through 32 source-backed administrator decisions across service endpoints, private endpoints, private DNS, Azure Load Balancer, health probes, and traffic distribution. How this practice exam works. You will hear the complete scenario, question, and every answer option. After lock in your answer, you will have 3 full seconds of silence, while the complete question and every option remain visible. Then the supported answer, or exact answer set, resolves in place, followed by the reason it fits and a decision pattern you can reuse. Pause whenever you need more thinking time. If you enjoy our videos, please like and subscribe to support the channel. Question 1 of 32. A virtual machine in App Subnet must access blobs in STG prod through the storage account public endpoint. Public network access on STG prod is limited to selected networks. No virtual network rule exists, and other subnets must remain denied. You must use a service endpoint and must not deploy a private endpoint. Which paired subnet and storage account configuration meets these requirements? Answer A. Enable the Microsoft.Storage Service Endpoint on App Subnet and add a storage virtual network rule for App Subnet. Answer B. Enable the Microsoft.Storage Service Endpoint on App Subnet and add an IP network rule for the virtual machine private address. Answer C. Enable the Microsoft.Storage Service Endpoint on Admin Subnet and add a storage virtual network rule for Admin Subnet. Answer D. Enable the Microsoft.SQL Service Endpoint on App Subnet and add a storage virtual network rule for App Subnet. Lock in your answer. Answer A is the complete service endpoint configuration. A. Enable the Microsoft.Storage Service Endpoint on App Subnet and add a storage virtual network rule for App Subnet. Enable the Azure Storage Service Endpoint on the workload subnet and admit that same subnet with a storage virtual network rule. The endpoint and the resource side network rule are complementary. Configuring either for a different subnet does not authorize App Subnet. For service endpoint access, align the service, source subnet, and destination resource rule. All 3 must describe the same path. Question 2 of 32. Clients in App VNet use the standard stg prod.blob.core.windows.net connection name. They must resolve that name to a private IP and reach only the Blob service through Azure Private Link. Public network access to the storage account must be disabled. Which endpoint, DNS, and public access plan should you implement? Answer A. Create a private endpoint targeting the Blob subresource. Link a private zone named blob.core.windows.net to App VNet and disable public network access on STG prod. Answer B. Create a private endpoint targeting the file subresource. Link private link.file.core.windows.net to App VNet and disable public network access on STG prod. Answer C. Create a private endpoint targeting the Blob subresource. Link private link.blob.core.windows.net to App VNet and disable public network access on STG prod. Answer D. Create a private endpoint targeting the Blob subresource. Link private link.blob.core.windows.net to App VNet and keep public network access enabled on STG prod. Lock in your answer. Answer C is the private-only Blob access plan. Create a Blob-targeted private endpoint and link the recommended private link.blob.core.windows.net private DNS zone to the client VNet. Disable public network access separately because creating private link does not close the storage public endpoint automatically. C. Create a private endpoint targeting the Blob subresource. Link privatelink.blob.core.windows.net to app vnet, and disable public network access on STG prod. Treat target subresource, private DNS, and public endpoint exposure as 3 separate controls. A correct private endpoint does not silently configure the other 2. Question 3 of 32. The public Azure DNS zone contoso.com hosts an application behind a standard SKU Azure Public IP resource. Users must browse to contoso.com at the zone apex, and DNS must follow the resource automatically if its public IP address changes. Which DNS record set configuration should you create? Answer A. Create a standard A record set named @ that contains the public IP resource's current IP version 4 address. Answer B. Create an A alias record set named @ that references the Azure public IP resource. Answer C. Create an A alias record set named www that references the Azure public IP resource. Answer D. Create a CNAME record set named @ that points to the public IP resource's DNS name. Lock in your answer. Answer B is the valid zone apex record. At the zone apex, use a resource-aware alias when the Azure target can change. A static A record preserves the old address, and a CNAME is not permitted there. Create an A alias record set at the @ and reference the standard public IP resource. Azure DNS alias records follow the target resource dynamically, while a CNAME cannot coexist with the Apex NS and SOA records. B. Create an A alias record set named @ that references the Azure public IP resource. Question 4 of 32. 2 application virtual machines in one virtual network listen on TCP 443. The service must be reached from Azure Virtual Networks and an on-premises network connected to Azure, but it must not expose an internet-facing front end. New connections must be distributed across healthy virtual machines through one stable private IP address. Which standard load balancer configuration meets the requirements? Answer A. Use an internal load balancer with a private front-end IP, a back-end pool containing both virtual machines, a TCP 443 health probe, and a load balancing rule from front-end 443 to back-end 443. Answer B. Use a public load balancer with a public front-end IP, a back-end pool containing both virtual machines, a TCP 443 health probe, and a load balancing rule from front-end 443 to back-end 443. Answer C. Use an internal load balancer with a private front-end IP, a back-end pool containing both virtual machines, a TCP 443 health probe, add one inbound NAT rule from front-end 443 to VM1 on back-end 443. Answer D. Use an internal load balancer with a private front-end IP, a back-end pool containing both virtual machines, a TCP 443 health probe, and an outbound rule for the back-end pool. Lock in your answer. Answer A is the internal load balancer design. Choose an internal standard load balancer because the front end must be private. Put both virtual machines in the backend pool. Probe TCP 443 and use a load balancing rule to map the private front-end port to the backend port. NAT and outbound rules solve different traffic directions. Start with the required client-facing IP type. Then verify that the selected rule actually distributes inbound traffic rather than forwarding to one instance or configuring egress. A. Use an internal load balancer with a private front-end IP, a back-end pool containing both virtual machines, a TCP 443 health probe, and a load balancing rule from front-end 443 to back-end 443. Question 5 of 32. A standard load balancer uses an HTTPS health probe on port 443 with request path /health. Both backend applications are healthy. Direct tests show that /health returns HTTP 302, root path returns HTTP 302, and /ready returns HTTP 200. The probe port is correct, and no NSG or guest firewall rule blocks probe traffic. What should you change to restore healthy probe status? Answer A. Keep /health and increase the unhealthy threshold while keeping port 443. Answer B. Change the HTTPS probe request path to root path and keep port 443. Answer C. Change the HTTPS probe request path to /ready and keep port 443. Answer D. Keep /health and increase the probe interval while keeping port 443. Lock in your answer. Answer C fixes the health probe path. C. Change the HTTPS probe request path to /ready and keep port 443. When an HTTP or HTTPS probe reaches the backend but remains down, compare the configured path with the exact status code returned. Timing changes do not repair a deterministic non-200 response. For HTTP and HTTPS probes, Azure Load Balancer treats HTTP 200 OK as success. The port is already correct and the network path is open, so point the probe at the application endpoint that returns 200, /ready. Question 6 of 32. App Subnet has a 0.0.0.0/0 user-defined route to a network virtual appliance for forced internet inspection. You enabled the Microsoft.Stored Service-Endpoint on App Subnet and want to verify that Azure Stored's traffic now uses the Service-Endpoint route while ordinary internet traffic remains forced through the appliance. Which effective route result confirms the Service-Endpoint is in effect? Answer A. The App Subnet virtual network address prefix appears with a next hop type of VNet local. Answer B. The Azure Storage address prefixes appear as more specific routes with a next hop type of internet. Answer C. Only the 0.0.0.0/0 route appears with a next hop type of virtual appliance. Answer D. The Azure Storage address prefixes appear as more specific routes with a next hop type of virtual network service endpoint. Lock in your answer. Answer D is the effective route result to verify. When validating a service endpoint, look for both the service-specific prefix and the virtual network service endpoint next hop. A default route alone proves nothing about the endpoint. D. The Azure Storage address prefixes appear as more specific routes with a next hop type of virtual network service endpoint. The effective route table should show a more specific route for Azure Storage address prefixes with next hop type virtual network service endpoint. That route is more specific than the forced tunnel default route and confirms the direct service path. Question 7 of 32. An application in Analytics VNet uses a hierarchical namespace-enabled storage account. It performs data lake file system and ACL operations through the DFS endpoint and also performs Blob operations. All of these calls must use private endpoints and private DNS. Which private endpoint set should you configure? Answer A. Create DFS and Blob private endpoints and link privatelink.dfs.core.windows.net and privatelink.blob.core.windows.net to Analytics VNet. Answer B. Create only a DFS private endpoint and link only privatelink.dfs.core.windows.net to Analytics VNet. Answer C. Create only a Blob private endpoint and link only privatelink.blob.core.windows.net to Analytics VNet. Answer D. Create file and blob private endpoints and link privatelink.file.core.windows.net and privatelink.blob.core.windows.net to Analytics VNet. Lock in your answer. Answer A is the required DFS and Blob endpoint set. Create separate DFS and Blob private endpoints and link both recommended private DNS zones. Azure Storage private endpoints are service-specific, and data lake workloads can require both DFS and Blob endpoints because some operations are redirected across them. A. Create DFS and Blob private endpoints and link private link.dfs.core.windows.net and private link.blob.core.windows.net to Analytics VNet. Option C. A Blob-only path omits DFS APIs, such as file system, directory, and ACL operations. Inventory every storage service hostname the application can call or be redirected to. Each consumed subresource needs its own private endpoint and matching private DNS zone. Question 8 of 32. The private DNS zonecorp.contoso.internal must be resolvable from Hub VNet and App VNet. Virtual machines in Hub VNet must register records automatically. Virtual machines in App VNet must resolve the zone, but must not register records. Dev VNet must not gain access to the zone. Which two virtual network links should you create? Answer A. Link Hub VNet to corp.contoso.internal with auto-registration enabled. Answer B. Link Hub VNet to corp.contoso.internal with auto-registration disabled. Answer C. Link App VNet to corp.contoso.internal with auto-registration enabled. Answer D. Link Dev VNet to corp.contoso.internal with auto-registration disabled. Answer E. Link App VNet to corp.contoso.internal with auto-registration disabled. Lock in your answer. A and E are correct. A. Link Hub VNet to corp.contoso.internal with auto-registration enabled. E. Link App VNet to corp.contoso.internal with auto-registration disabled. Create a registration link for Hub VNet and a resolution-only link for App VNet. Auto-registration controls automatic VM record creation. A link without auto-registration still permits the linked VNet to query the private zone. Option C. This would automatically create records for App VNet virtual machines, violating the resolution-only requirement. For each private DNS link, decide independently whether the VNet needs resolution, automatic registration, both, or neither. Question 9 of 32. An internet-facing HTTPS service runs on two virtual machines in one virtual network. The virtual machines must not receive public IP addresses. Clients must use one public IP on TCP 443, and new connections must be sent only to instances whose HTTPS/health endpoint responds successfully on port 443. Which standard load balancer configuration should you deploy? Answer A. Use a private front-end IP. Add both VM private IP configurations to one backend pool. Configure an HTTPS 443/health probe and add a load balancing rule from front-end 443 to backend 443. Answer B. Use a public front-end IP. Add both VM private IP configurations to one backend pool. Configure an HTTPS 443/health probe and add only an outbound rule for the backend pool. Answer C. Use a public front-end IP. Add both VM private IP configurations to one backend pool. Configure an HTTPS 443/health probe. Add one inbound NAT rule from Frontend 443 to VM1 on Backend 443. Answer D. Use a public frontend IP. Add both VM private IP configurations to one backend pool. Configure an HTTPS 443/health probe and add a load balancing rule from Frontend 443 to Backend 443. Lock in your answer. Answer D is the public load balancer configuration. Option A. A private front-end creates an internal load balancer and cannot provide the required internet-facing endpoint. A public front-end makes the load balancer reachable from the internet. The back-end virtual machines can remain private. Add both VM private IP configurations to the back-end pool. Use the HTTPS health probe and create the inbound load balancing rule for TCP 443. D. Use a public front-end IP. Add both VM private IP configurations to one backend pool. Configure an HTTPS 443/health probe and add a load balancing rule from frontend 443 to backend 443. A public load balancer needs a public front-end, not public IP addresses on every backend. Separate front-end exposure from backend membership. Question 10 of 32. A standard load balancer rule maps front-end TCP 443 to back-end TCP 9000. Its TCP health probe also uses port 9000. Both back-end services are running and listening on 0.0.0.0 on port 9000. However, the effective NSG rules contain a priority 100 deny for Azure load balancer traffic to TCP 9000. Windows Defender Firewall blocks inbound traffic from 168.63.129.16 to TCP 9000. The backend pool membership is correct. Which two changes are required to restore the probes while preserving the application port design? Answer A. Change the load balancing rule backend port from 9000 to 443. Answer B. Enable floating IP on the existing load balancing rule. Answer C. Add an inbound NAT rule that forwards a front-end port to backend TCP 9000. Answer D. Allow inbound traffic from 168.63.129.16 to TCP 9000 in Windows Defender Firewall. Answer E. Create a higher priority NSG allow rule for Azure load balancer traffic to TCP 9000. Answer F. Change the load balancing rule distribution mode to client IP. Lock in your answer. D and E are correct. The probe configuration and listener already agree on TCP 9000. Two independent security layers block the health probe, the effective NSG and the guest firewall. Allow Azure Load Balancer probe traffic at both layers, while leaving the application and load balancing rule ports unchanged. Option B. Floating IP changes load balancing rule behavior, but does not permit probe packets through either security control. D. Allow inbound traffic from 168.63.129.16 to TCP 9000 in Windows Defender Firewall. E. Create a higher priority NSG allow rule for Azure Load Balancer traffic to TCP 9000. A healthy listener can still be probed down when multiple security layers block the platform probe. Enumerate every independent blocker before changing the load balancing rule. Question 11 of 32. App Subnet is an East-US. Applications in the subnet must access the public endpoints of STG primary in East-US and STG-DR in West-US. Both storage accounts will allow App Subnet with virtual network rules. You must configure one Azure Storage Service endpoint type on App Subnet that supports both accounts. Which endpoint type and account rule configuration supports both destinations? Answer A. Enable Microsoft.storage on App Subnet and add an App Subnet virtual network rule to both storage accounts. Answer B. Enable Microsoft.storage.global on App Subnet and add an App Subnet virtual network rule to both storage accounts. Answer C. Enable Microsoft.storage.global on Operations Subnet and add an App Subnet virtual network rule to both storage accounts. Answer D. Enable both Microsoft.storage and Microsoft.storage.global on App Subnet and add an App Subnet virtual network rule to both storage accounts. Lock in your answer. Answer B supports both storage destinations. Choose the storage endpoint type from the destination region requirement. Then place it on the actual source subnet and mirror that subnet in every destination account role. Use Microsoft.storage.global on App Subnet because the workload must reach storage accounts in multiple regions. Add App Subnet as a virtual network rule on each account. A subnet can have only one of Microsoft.storage or Microsoft.storage.global. Option A. Microsoft.storage provides same region connectivity, so it does not satisfy the stated cross-region storage account path to West US. B. Enable Microsoft.storage.global on App Subnet and add an App Subnet virtual network rule to both storage accounts. Question 12 of 32. An application team created a private endpoint by using the manual approval method because it lacks the private link resource approval permission. The endpoint DNS settings are already correct, but the private endpoint connection status is pending. Which connection action is required before the endpoint can send traffic? Answer A. Have the private link resource owner reject the existing pending private endpoint connection. Answer B. Have the endpoint owner delete the pending endpoint and submit another manual connection request. Answer C. Have the endpoint owner delete the pending endpoint and recreate it with automatic approval while retaining the same permissions. Answer D. Have the private link resource owner approve the existing pending private endpoint connection. Lock in your answer. Answer D is the required connection state action. D. Have the private link resource owner approve the existing pending private endpoint connection. Option A, rejected, is a non-active state and prevents the endpoint from sending traffic. When DNS is healthy but a private endpoint is pending, troubleshoot the consent state, not the name resolution or subnet path. The private link resource owner must approve the pending connection. Manual requests remain pending until the resource owner approves them, and only private endpoints in the approved state can send traffic. Question 13 of 32. A hub virtual network hosts a private endpoint. The existing private DNS zone privatelink.database.windows.net is linked to the hub and to Spoke A. Spoke A and Spoke B are each peered with the hub. Clients in both spokes must resolve the same private endpoint records. Spoke B currently cannot resolve them, and virtual machines in Spoke B must not auto-register records in the zone. Azure Private Resolver and custom DNS servers are not in use. Which Azure DNS configuration should you add? Answer A. Replace the existing Spoke A link with a resolution-only link from the existing private DNS zone to Spoke B. Answer B. Create another private DNS zone with the same name and add a resolution-only link from that new zone to Spoke B. Answer C. Add a resolution-only virtual network link from the existing private DNS zone to Spoke B. Answer D. Add an auto-registration-enabled virtual network link from the existing private DNS zone to Spoke B. Lock in your answer. Answer C extends private DNS resolution to Spoke B. Answer C. A resolution-only link lets Spoke B query records in the existing zone without auto-registering Spoke B VM records. Virtual network peering does not by itself extend a private DNS zone to every client VNet. Link Spoke B to the existing zone. Because Spoke B needs resolution, but not VM record registration, create the link with auto-registration disabled. For Azure Private DNS, treat VNet reachability and zone linkage as separate controls. Choose registration only when the VNet should publish VM records automatically. C. Add a resolution-only virtual network link from the existing private DNS zone to Spoke B. Question 14 of 32. Two vendor-supported network virtual appliances run in one virtual network. They must receive internal TCP and UDP flows on every destination port through one private front-end IP. One rule must cover all ports, and per-instance health probes must remove failed appliances from new flow rotation. The vendor requires a non-floating configuration. Which load balancing configuration should you use? Answer A. Use an internal standard load balancer. Add both NVA devices to one backend pool. Configure a per-instance health probe, and create one rule with protocol TCP, front-end and backend ports 0, and floating IP disabled. Answer B. Use an internal standard load balancer. Add both NVA devices to one backend pool. Configure a per-instance health probe, and create one HA ports rule with protocol all, front-end and backend ports 0, and floating IP disabled. Answer C. Use a public standard load balancer. Add both NVA devices to one backend pool. Configure a per-instance health probe, and create one HA ports rule with protocol all, front-end and backend ports 0, and floating IP disabled. Answer D. Use an internal standard load balancer. Add both NVA devices to one backend pool. Configure a per-instance health probe, and create separate port-specific TCP and UDP rules with floating IP disabled. Lock in your answer. Answer B is the all ports internal distribution design. HA ports is the internal standard load balancer rule designed for NVA devices and all port traffic. Configure protocol all and set both front-end and back-end ports to 0. Because the vendor requires non-floating operation, leave floating IP disabled. Answer B. An internal standard load balancer HA ports rule with protocol all and ports 0 balances TCP and UDP flows across all ports. The non-floating form keeps floating IP disabled. B. Use an internal standard load balancer, add both NVA devices to one backend pool, configure a per-instance health probe, and create one HA ports rule with protocol all, front-end and backend ports 0, and floating IP disabled. When the requirement says every TCP and UDP port through one internal rule, test for the HA ports tuple, internal standard, protocol all, and ports 0. Question 15 of 32. A public standard load balancer distributes HTTPS traffic to two virtual machines. Health probe status is 100%, but public clients time out. Effective routes on both backend network interfaces show a BGP learned 0.0.0.0/0 route, whose next hop is the virtual network gateway. The network owner approves a route exception for only the backend subnet so that replies to internet clients return through the public load balancer path. Which route should you configure on the backend subnet? Answer A 0.0.0.0/0 user-defined route with next hop virtual network gateway. Answer B, a 168.63.129.16/32 user-defined route with next hop internet. Answer C, a 10.0.0.0/8 user-defined route with next hop internet. Answer D, a 0.0.0.0/0 user-defined route with next hop internet. Lock in your answer. Answer D restores the symmetric return path. When probes are healthy but public clients time out, inspect backend effective routes for an asymmetric default path. Correct the client response route without changing a healthy probe. D. A 0.0.0.0/0 user-defined route with next hop internet. Answer D. For the same 0.0.0.0/0 prefix, the user-defined route takes priority over the BGP learned route and restores the internet return path required for symmetric public load balancer flows. Associate the backend subnet with a route table containing a 0.0.0.0/0 user-defined route, whose next hop is internet. That route overrides the BGP learn default through the virtual network gateway for the backend subnet, restoring the symmetric return path expected for public load balancer flows. Question 16 of 32. Virtual machines in App Subnet must reach an Azure storage account through its public endpoint. The storage firewall must admit only App Subnet. App Subnet has no Azure Storage Service-Endpoint, and the storage account has no virtual network rule for App Subnet. The existing DNS name must continue to resolve to the service's public IP address. A private endpoint must not be created. Which two actions should you perform? Answer A. Add batch subnet as a virtual network rule on the storage account. Answer B. Enable the Microsoft.Storage service endpoint on App Subnet. Answer C. Create a private endpoint for the storage account in App Subnet. Answer D. Allow public network access from all networks on the storage account. Answer E. Add App Subnet as a virtual network rule on the storage account. Lock in your answer. B and E are correct. Enable the Microsoft.Storage service endpoint on App Subnet and add App Subnet as a virtual network rule on the storage account. The subnet setting supplies the service endpoint path and identity, while the storage rule admits that specific subnet. Their final configuration matters. No universal exact ordering is required. B. Enable the Microsoft.Storage service endpoint on App Subnet. E. Add App Subnet as a virtual network rule on the storage account. Service endpoint access requires both a source subnet endpoint and a destination service network rule. Diagnose the two control planes separately without inventing an order requirement that the scenario does not establish. Option A. A rule for batch subnet admits a different source subnet and does not authorize workloads originating in App Subnet. Question 17 of 32. A standard load balancer backend pool should contain two running virtual machines. The pool currently lists 3 NICIP configurations. 2 network interfaces belong to the running virtual machines and pass their probes. The third NIC remains from a deleted VM. Querying it returns VM ID as null, and that stale pool entry is always down. The 2 valid virtual machines must remain in service. What should you do to correct the backend pool condition? Answer A. Remove the ghosted NICIP configuration from the backend pool. Keep the 2 valid network interfaces and recheck backend health. Answer B. Increase the health probe threshold for the ghosted NIC while keeping all 3 pool entries. Answer C. Enable floating IP on the load balancing rule while keeping all 3 pool entries. Answer D. Create an NSG allow rule for the ghosted NIC while keeping all 3 pool entries. Lock in your answer. Answer A removes the invalid backend member. Option B. A probe threshold cannot make a detached NIC serve traffic. The invalid backend reference must be removed. A. Remove the ghosted NICIP configuration from the backend pool. keep the two valid network interfaces, and recheck backend health. The failing entry is not a probe tuning or security problem. It is stale backend pool membership. Remove the ghosted NIC reference, retain the two valid network interfaces, and rerun the pool and health checks. When a backend reference no longer resolves to a running resource, repair pool membership before tuning probes or load balancing rule features. Question 18 of 32. An Azure DNS public zone named apps.example.com already exists. Its assigned Azure DNS name servers are recorded, and administrators can edit the parent example.com zone at the registrar. The team must delegate the child namespace and verify that public queries reach Azure DNS. Which two actions should the administrators perform? Answer A. Create a CNAME record for apps in the parent zone that points to one assigned Azure DNS name server. Answer B. Query the SOA record for apps.example.com and confirm that an assigned Azure DNS name server answers. Answer C. Create NS records for apps in the parent zone that name the Azure DNS servers assigned to apps.example.com. Answer D. Replace the child zone SOA primary server value with the registrar name server. Answer E. Clear a workstation DNS cache and verify only its local host file entry for apps.example.com. Answer F. Create an A record for apps in the parent zone that points to an IP address of an Azure DNS name server. Lock in your answer. B and C are correct. B. Query the SOA record for apps.example.com and confirm that an assigned Azure DNS name server answers. C. Create NS records for apps in the parent zone that name the Azure DNS servers assigned to apps.example.com. Create parent zone NS records for apps that reference the Azure DNS name servers assigned to the child zone. Then, query the child SOA record and confirm that an assigned Azure DNS server answers. Delegation is created at the parent. Verification must test public authority rather than a local alias or cache. Public child zone delegation has two distinct jobs. Publish the parent NS referral, then verify that an authoritative child zone server answers. Option D. Editing the child SOA record does not create the required referral from the parent zone. Question 19 of 32. Two application virtual machines in Backend Pool 1 listen on TCP port 8080 and expose their health listener on TCP port 8080. Private workloads in the same virtual network must connect through one virtual IP and have new flows distributed across healthy pool members. Internet-originated connections are prohibited. The backend pool is already populated, but the load balancer has no front-end, probe, or traffic rule. Which three configurations should you create? Answer A. A front-end IP configuration that uses a public IP address. Answer B. An inbound NAT rule that maps the front end on TCP 8080 to one specific virtual machine. Answer C. A front-end IP configuration that uses a private IP address in the virtual network. Answer D. A TCP health probe that checks backend port 8080. Answer E. A load balancing rule that maps the private frontend on TCP 8080 to backend pool 1 on TCP 8080 and references the probe. Lock in your answer. C, D, and E are correct. For private tier distribution, trace the full internal load balancing path: private frontend, populated backend pool, health probe, and a rule that connects the listener to the pool. A private frontend creates an internal load balancer rather than an intranet-facing one. The probe determines which backend instances are healthy, and the load balancing rule maps the private frontend and service port to the multiple addresses in backend pool 1. Together, they distribute new flows only to healthy instances. C. A front-end IP configuration that uses a private IP address in the virtual network. D. A TCP health probe that checks backend port 8080. E. A load balancing rule that maps the private frontend on TCP 8080 to backend pool 1 on TCP 8080 and references the probe. Option A. A public frontend creates an internet-facing load balancer boundary, contrary to the private-only requirement. Question 20 of 32. A storage account named ST shared has a private endpoint whose target subresource is Blob. A new workload in the virtual network must mount an Azure file share in ST shared. Public network access will be disabled after the new path is validated. The existing Blob private endpoint must remain available. What should you configure for the new workload? Answer A. Reuse the existing private endpoint because Blob also represents the Azure Files data plane. Answer B. Create another private endpoint for ST shared and select Blob as its target subresource. Answer C. Enable an Azure storage service endpoint on the subnet instead of selecting a target subresource. Answer D. Create another private endpoint for ST shared and select File as its target subresource. Lock in your answer. Answer D targets the Azure Files data plane. Answer D. An additional endpoint with the file target maps its private network interface to the required Azure Files subresource. D. Create another private endpoint for ST shared and select File as its target subresource. When one service account exposes multiple data planes, derive the private endpoint target from the workload protocol rather than from the account name or an existing sibling endpoint. A private endpoint connects to the selected target subresource. The existing Blob endpoint represents the Blob data plane, not Azure Files. Create a separate private endpoint for ST shared with File as the target, so its private network interface maps to the data plane the workload mounts. Validate that target before public access is disabled. Question 21 of 32. Compute instances in Data Subnet use an Azure Storage Service Endpoint. They must send storage traffic only to 2 approved Azure Resource Manager storage accounts. Access from Data Subnet to every other storage account must be denied. The requirement is to restrict outbound destinations from the subnet, not to assign private IP addresses or change the storage account's source admission rules. What should you configure? Answer A. Add a virtual network firewall rule for Data Subnet to every approved storage account. Answer B. Associate an Azure Storage Service-Endpoint policy listing the 2 approved storage accounts with Data Subnet. Answer C. Link a private DNS zone containing only the 2 approved storage account names to Data Subnet's virtual network. Answer D. Associate a generic service endpoint policy that allows every platform as a service resource in the subscription with Data Subnet. Lock in your answer. Answer B. Constrains service endpoint destinations. An Azure Storage Service Endpoint policy filters egress over the subnet's existing storage service endpoint. Associate the policy with Data Subnet and list only the 2 approved storage account resources. Compute in the subnet can then access the listed resources, while other storage accounts are denied. Distinguish a source subnet egress allow list from a destination services inbound firewall rule. They enforce opposite sides of the connection. Option C. Private DNS controls name resolution and does not enforce an Azure Storage Service Endpoint Destination Allow policy. B. Associate an Azure Storage Service Endpoint policy listing the 2 approved storage accounts with Data Subnet. Question 22 of 32. A private endpoint is deployed in Subnet PE. Its connection is approved, and the service fully qualified domain name resolves from the client network to the endpoint's private IP address. An NSG is associated with Subnet PE, but the security team reports that the intended NSG control is not being applied to private endpoint traffic. The setting must affect the private endpoints in this subnet without changing the working connection or DNS configuration. What should you configure first? Answer A. Create a service-endpoint policy on Subnet PE for the platform as a service resource. Answer B. Enable private endpoint network policy support for network security groups on Subnet PE. Answer C. Submit another approval request for the existing private endpoint connection. Answer D. Link an additional private DNS zone to the client virtual network. Lock in your answer. Answer B enables NSG policy support on the private endpoint subnet. Option A. A service endpoint policy belongs to service endpoint architecture and does not enable network policy support for a private endpoint. When a private endpoint is connected and resolves correctly, but an NSG or route control does not govern its traffic, inspect the private endpoint network policy state of the hosting subnet before changing other layers. Private endpoint network policy support must be enabled on the endpoint subnet before supported NSG controls can apply to private endpoints there. The setting affects all private endpoints in the subnet. Connection approval and private DNS are already healthy and are separate controls. B. Enable private endpoint network policy support for network security groups on Subnet PE. Question 23 of 32. A private DNS zone named corp.internal is used by 3 virtual networks. VNet workload must automatically register A records for its virtual machines and must resolve all zone records. VNet app and VNet ops must resolve the zone, but virtual machines in those networks must not create records automatically. The zone namespace cannot be changed. Which virtual network link plan should you use? Answer A. VNet workload, link with auto-registration enabled. VNet app, link with auto-registration enabled. VNet ops, link with auto-registration enabled. Answer B. VNet workload, link with auto-registration disabled. VNet app, link with auto-registration enabled. VNet ops, link with auto-registration enabled. Answer C. VNet workload, link with auto-registration disabled. VNet app, link with auto-registration disabled. VNet ops, link with auto-registration disabled. Answer D. VNet workload, link with auto-registration enabled. VNet app, link with auto-registration disabled. VNet ops, link with auto-registration disabled. Lock in your answer. Answer D is the correct private DNS link plan. D. VNet workload, link with auto-registration enabled. VNet app, link with auto-registration disabled. VNet ops, link with auto-registration disabled. Treat private zone resolution and VM auto-registration as separate per link decisions. Every client network may need a link, but only designated record-owning networks should register automatically. Option B. This plan disables required registration in VNet workload and enables unwanted registration in VNet app and VNet ops. Create a virtual network link for all 3 networks so each can resolve the zone. Enable auto-registration only on the VNet workload link. Keep auto-registration disabled on the VNet app and VNet ops links so those networks can resolve names without automatically contributing VM records. Question 24 of 32. A public standard load balancer has front-end configurations named FE Customer and FE Operations. Customers connect only to FE Customer on TCP port 443. AppPool is populated with application instances that listen on TCP port 8443, and Probe 8443 checks that listener. The load balancing rule must not use source IP affinity so that new connections from the same client are not required to remain with the same backend instance. Which load balancing rule configuration meets the requirements? Answer A. FE Customer, TCP Frontend port 443, App Pool, Backend port 8443, Probe 8443, Session persistence none. Answer B. FE Customer, TCP Frontend port 443, App Pool, Backend port 8443, Probe 8443, Session persistence Client IP. Answer C. FE Customer, TCP Frontend port 443, App Pool, Backend port 443, Probe 8443, Session persistence none. Answer D. FE Operations, TCP Frontend port 443, App Pool, Backend port 8443, Probe 8443, Session persistence none. Lock in your answer. Answer A maps the customer frontend to the application backend. Treat the rule as one binding across the selected frontend port, backend pool and service port, health probe, and persistence mode. Every element must satisfy the scenario. Option B. Client IP session persistence enables source IP affinity, directly violating the requirement that the rule not use that persistence mode. A. FE Customer TCP Frontend port 443, App Pool Backend port 8443, Probe 8443, Session persistence none. A load balancing rule must reference the frontend that receives client traffic, map its frontend port to the port on which the backend application listens, and use the applicable health probe. Session persistence none satisfies the explicit requirement not to use source IP affinity. Client IP persistence does not. Question 25 of 32. A load balancing rule references a probe that currently checks HTTPS port 443 at path root path. Each backend application listens on HTTPS port 8443. A request to /health on port 8443 returns HTTP 200, while a request to root path on that port returns HTTP 404. Nothing listens on port 443. Effective NSG rules and routes allow the probe traffic, but health probe status reports the backends as unhealthy. The entire backend HTTPS certificate chain uses SHA 256 or stronger signature hashes. How should you modify the health probe? Answer A. Set the protocol to HTTPS, the port to 8443, and keep the path as root path. Answer B. Set the protocol to HTTPS, the port to 8443, and the path to /health. Answer C. Keep the protocol as HTTPS and the port as 443, and set the path to /health. Answer D. Keep the protocol, port, and path unchanged, and increase only the probe interval. Lock in your answer. Answer B aligns the probe with the protected HTTPS endpoint. The HTTPS certificate chain meets the probe requirement. Configure the probe for HTTPS port 8443 at /health, the demonstrated endpoint that returns HTTP 200. With the certificate, NSG, route, listener, port, and path prerequisites satisfied, the backend can become healthy and eligible for new flows. Option D. Changing timing does not repair the demonstrated port and path mismatch. When reachability is valid but a backend is unhealthy, compare the probe's protocol, destination port, and request path with the endpoint that actually returns success. B. Set the protocol to HTTPS, the port to 8443, and the path to /health. Question 26 of 32. A virtual machine in App Subnet cannot reach an Azure storage account. The storage firewall already contains a virtual network rule for App Subnet. A neighboring subnet named Batch Subnet has the Microsoft.Storage Service-Endpoint enabled, but App Subnet does not. DNS from the virtual machine correctly resolves the storage service name to its public IP address. The application's storage authorization is valid. What should you do to restore the required network path? Answer A. Create a private DNS record for the storage account in App Subnet. Answer B. Assign another storage data role to the virtual machine identity. Answer C. Enable an additional Microsoft.Storage Service endpoint on Batch Subnet. Answer D. Enable the Microsoft.Storage Service endpoint on App Subnet. Lock in your answer. Answer D restores the service endpoint path on the workload subnet. D. Enable the Microsoft.Storage Service endpoint on App Subnet. Option B. Authorization is already valid, and a data role cannot provide the missing subnet network path. Service endpoints are enabled per subnet. Because the workload originates in App Subnet, the Microsoft.Storage endpoint must be enabled on App Subnet. The endpoint on Batch Subnet does not cover it. The existing storage account rule can then recognize service traffic from the intended subnet. Public DNS resolution is expected for a service endpoint and does not require correction. Troubleshoot subnet scoped features against the workload's actual source subnet, not a nearby subnet with a similar configuration. Question 27 of 32. An administrator manually creates a private endpoint for a platform-as-a-service resource owned by another team. The endpoint network interface and private IP exist. Client routing is valid, and the service name resolves to the private IP. The service-side private endpoint connection state is pending. The application already has its required data plane role assignment. Which action must occur before the application can send traffic to the resource through the private endpoint? Answer A. Assign the same data plane role to the private endpoint network interface. Answer B. Add an NSG allow rule for the application's data plane identity. Answer C. Have the platform as a service resource owner approve the pending private endpoint connection. Answer D. Add another private DNS record for the service name. Lock in your answer. Answer C opens the pending private endpoint connection. Answer C. Owner approval changes the manual connection from pending to approved and makes the private link ready for use. Treat private endpoint connection state as a gate before diagnosing application credentials when routing and private name resolution are already valid. A manually created connection remains pending until the private link resource owner approves it. Only private endpoints in the approved state can send traffic to the specified private link resource. Application authorization remains a separate layer and is already satisfied here. C. Have the platform as a service resource owner approve the pending private endpoint connection. Question 28 of 32. A standard load balancer distributes TCP 443 connections to two virtual machines. Its TCP health probe targets port 8080. Backend pool membership, the load balancing rule, and the probe configuration are correct. On both virtual machines, the application listens on port 8080, and the guest firewall permits that port. Health probe status still reports both backends as unhealthy. The effective NIC and subnet NSG evaluation shows that inbound traffic from the Azure Load Balancer service tag to destination TCP port 8080 is blocked. Which NSG change should you make to restore backend health while limiting the change to the probe traffic? Answer A. Correct the effective inbound NSG block so traffic from the Azure Load Balancer service tag can reach destination TCP port 8080. Answer B. Add an inbound NSG allow rule from the Internet service tag to destination TCP port 443. Answer C. Correct the effective inbound NSG block so traffic from the Azure Load Balancer service tag can reach destination TCP port 443. Answer D. Add an outbound NSG allow rule to the Azure Load Balancer service tag on destination TCP port 8080. Lock in your answer. Answer A corrects the inbound health probe boundary. Option B, Internet to 443 is the client flow boundary and does not admit the Azure Load Balancer health probe to TCP 8080. The effective inbound NSG configuration blocks health probe traffic from the Azure Load Balancer source to TCP port 8080. Correcting that inbound block so the Azure Load Balancer probe can reach TCP 8080 addresses the demonstrated failure while remaining limited to the probe path. An Internet to 443 client rule, an outbound rule, or an allow to TCP 443 does not admit the configured probe. For a failed load balancer probe, match the effective NSG results direction, probe source boundary, protocol, and destination port to the configured health endpoint. A. Correct the effective inbound NSG block so traffic from the Azure Load Balancer service tag can reach destination TCP port 8080. Question 29 of 32. The public zone fabricam.example is already delegated to Azure DNS. A cutover must make the zone apex fabricam.example target a resource that Azure DNS identifies as a supported Azure resource alias target. The solution must preserve the current delegation and must not publish a fixed IP version 4 address. Which record configuration should you use? Answer A. Create a CNAME record at the zone apex and enter the resource's canonical DNS name. Answer B. Create an A record at the zone apex and enter the resource's canonical DNS name as its data. Answer C. Create an Azure DNS alias record at the zone apex and select the supported Azure resource as its target. Answer D. Create a CNAME record at the www label and leave the zone apex unchanged. Lock in your answer. Answer C is the supported Apex alias configuration. Choose public DNS record type from both target form and label position. IP version 4 uses A, a non-Apex canonical name uses CNAME, and a supported Azure resource target can use an Apex alias. Answer C. An Azure DNS alias can be created at the apex and can target the stated supported Azure resource. C. Create an Azure DNS alias record at the zone apex and select the supported Azure resource as its target. A CNAME cannot be created at the zone apex because the apex contains the zone's NS and SOA record sets. For an explicitly supported Azure resource, an Azure DNS alias record provides apex support without requiring a fixed IP version 4 address or a delegation change. Question 30 of 32. Storage 1 uses its public endpoint and has separate virtual network rules for archive subnet, app subnet, and report subnet. Archive subnet is being retired and must lose its service endpoint path to storage 1, while app subnet and report subnet must remain authorized. Archive subnet does not use its Microsoft.storage service endpoint for any other storage account, and the endpoint must be deconfigured as part of the retirement. Private endpoints are not part of the approved architecture. No critical task or open connection is running from archive subnet. Which action should you perform to retire the complete storage 1 service endpoint path for archive subnet? Answer A. Remove archive subnet's virtual network rule from storage 1, and then disable the Microsoft.storage service endpoint on archive subnet. Answer B. Remove every virtual network rule from storage 1, and then disable the Microsoft.storage service endpoint on archive subnet. Answer C. Disable the Microsoft.storage service endpoint on archive subnet, but leave all storage 1 virtual network rules unchanged. Answer D. Create a private endpoint for storage 1 in archive subnet. Lock in your answer. Answer A retires both layers of the service endpoint path. Retiring the service endpoint path requires removing archive subnet's selected virtual network rule from storage 1 and disabling the Microsoft.storage service endpoint on archive subnet when that endpoint is no longer needed for any storage account. The scoped rule removal preserves app subnet and report subnet. Removing all rules is overbroad. Disabling only the endpoint leaves the account-side authorization configured, and a private endpoint creates a different path rather than retiring the existing one. A. Remove archive subnet's virtual network rule from storage 1, and then disable the Microsoft.storage service endpoint on archive subnet. Option C. Disabling only the subnet service endpoint does not remove archive subnet's configured virtual network rule from storage 1. Question 31 of 32. Two redundant network virtual appliances are in the backend pool of an internal standard load balancer. Their provider has confirmed support for HA ports in this topology. Every TCP and UDP flow arriving on the internal front end must be distributed to the healthy appliances, regardless of port number. Per instance health probes are already configured. Which rule configuration should you create? Answer A. One rule with front-end port 0, back-end port 0, and protocol TCP. Answer B. One HA ports rule on a public front-end with front-end port 0, back-end port 0, and protocol all. Answer C. One HA ports rule with front-end port 0, back-end port 0, and protocol all. Answer D. Separate ordinary TCP and UDP rules for a finite list of currently known service ports. Lock in your answer. Answer C is the HA ports rule. C. One HA ports rule with front-end port 0, back-end port 0, and protocol all. Answer C. Ports 0 and protocol all express the HA ports behavior required for all TCP and UDP ports on the internal front end. For an internal appliance pool that must handle all TCP and UDP ports, recognize the HA port signature. Both ports are 0 and protocol is all, subject to provider-supported topology. HA ports on an internal standard load balancer distributes all supported protocol flows on all ports. The rule is configured with front-end and back-end ports set to 0 and protocol set to all. This avoids enumerating individual ports while retaining redundant pool distribution. Question 32 of 32. A private endpoint for a platform as a service resource is approved. A central team has created the Microsoft-recommended private DNS zone for the service, but the zone has no record sets and is not currently used by any virtual network. Workloads in Client VNet use Azure-provided DNS and must continue using the service fully qualified domain name. Client VNet is distinct from the endpoint virtual network. Governance requires Azure to manage the endpoint record lifecycle through Private-Endpoint integration. Administrators must not publish public overrides or maintain Endpoint A records manually. Which two configurations meet the DNS and record lifecycle requirements? Answer A. Create a virtual network link between the private DNS zone and client VNet. Answer B. Create and maintain a private A record manually in the zone for the private endpoint address. Answer C. Create a virtual network link between the private DNS zone and only the endpoint virtual network. Answer D. Add a private DNS zone group to the private endpoint and select the service's recommended private DNS zone. Answer E. Enable the Platform as a Service resources virtual network service endpoint on client VNet. Lock in your answer. A and D are correct. Evaluate Private-Endpoint DNS at two distinct scopes: endpoint managed registration in the service-appropriate private zone, and zone visibility from the virtual network where clients query Azure DNS. A. Create a virtual network link between the private DNS zone and client VNet. D. Add a private DNS zone group to the private endpoint and select the service's recommended private DNS zone. A private DNS zone group supplies lifecycle managed association between the private endpoint and the service-appropriate private DNS zone, including management of the endpoint record. A virtual network link gives client VNet visibility into that zone. Together, they make the service fully qualified domain name resolved to the endpoint's private IP for client VNet workloads. Option E. A service endpoint retains public service DNS behavior and does not configure private endpoint name resolution. Confidence check. For each private connectivity or load balancing decision, identify the endpoint boundary, name resolution path, front-end and back-end flow, probe result, and distribution rule. If you can explain those checks, you are building administrator judgment rather than memorizing isolated settings. Thanks for practicing private connectivity and load balancing with WebLizard Labs CertLab. Keep tracing the private path, validating name resolution, and checking the health signal before changing production traffic.